Hello everyone, I am Srisha. I am from CSC AML branch. Today my Tech Talk topic is graph combinations, theory and applications in network analysis. So my subject is essential of problem solving. So, introduction to graph combinations. Graph theory provides a framework for representing networks. Graph combination involve merging or relating multiple graphs to analyze complex systems used in computer science, communication networks, and social analysis. They help model interactions between different subnetworks or systems. Graph theory deals with the study of vertices like nodes and edges, connections. They represent relationships between objects. Graph combinations involve constructing new graphs by combining two or more exciting graphs in various ways to analyze complex systems. So, types of graph combinations. There are several types of graph combinations, but here majorly consist of four types. First is union of graphs. Union of graph combines all vertices and edges from both graphs. Second one, intersection of graphs. It contains only common vertices and edges. Cartesian product connects various based on pairs from two graphs. Composition connects nodes of one graph according to adjacency in another. These are the four types of graph combinations. Now let us see the examples for this. Here we have union of graphs. Here we took G1 graph with vertices A, B, D, C with four edges E1, E2, E3, E4 with combining G2 graph with vertices B, E, D of edges E4, E5, E6. Here union of graphs is nothing but combining two graphs and it's symbolized as capital U. So G1 union G2 is gives us A, B, E, D, C. So E1, E5, E6, E3, E2 and E4. Similarly, intersection of graphs. So here we took G1 graph as A, B, D, C vertices with edges E2, E3, E4 and E1 and with G2 as graph of vertices B, E, D with edges E4, E5 and E6. Here intersection is nothing but taking the common element in both graphs. So it is represent as reverse U, G1 intersection G2. The resultant is BD vertices with E4 as edge. Next, going to Cartesian of two graphs. Here Cartesian is nothing but product of two graphs. Here we took G1 graph with U1 V1 vertices and G2 graph with U2 V2 W2 vertices. Now Cartesian of two graphs G1 cross G2 has resultant shown in the given figure. Mathematical representation. So let G1 of V1 E1 and G2 of V2 E2 be the two graphs. So union G is equals to G1 union G2 where V is equals to V1 union V2 and E is equals to E1 union E2. Intersection. Intersection of two graphs where G is equals to G1 intersection G2 where V is equals to V1 intersection V2 and E is equals to E1 intersection E2. Cartesian product. G is equals to G1 cross G2 with vertex set V1 cross V2. Here G is nothing but two graphs, V is nothing but set of vertices of two graphs and E is nothing but edges of two graphs. Next, we are moving to applications in neural analysis. Graph combinations are used in analyzing multi-layered networks. Example, transportation systems, internet topology, and social networks. It helps in identifying overlapping communities or shared nodes, used in optimization, reliability, and flow analysis of networks. So, here there are some applications. There are five applications. So, first one is communication network. It combining subnetworks like routers or LANs to form a complete communication map. Second one is social network analysis, used to merge data from different communities or platforms to understand overall social influence or information flow. Third one, transportation system, merging road, rail, and air transport networks for integrated route planning. And fourth one is power and utility network, combining multiple regional power grids to analyze fault tolerance and load distribution. Fifth one is biological and neural networks. This is the most important and this is the most important application in our network analysis. So, which is now using frequently. So, it is used to integrate metabolic and protein interaction networks for biological insights. These are the five applications in network analysis. Next, we are moving to advantages and challenges. So, the advantages are it simplifies large scale system modeling, it enhances understanding of relationship between subsystems. So, next, the challenges. Computational complexity increases with graph size, visualization, and data handling can become difficult. These are the advantages and challenges. Now, let us look at case study example. There is an example that combining road and communication networks to analyze emergency response system. Union graph shows all possible connection for resource distribution. Intersection graph highlights shared critical paths or nodes. Such models improve coordination in real world network planning. This is the case study example we took. So the final part, conclusion. Graph combination enhance problem solving in complex network system. They bridge mathematical theory with real world application, useful in designing, analyzing, and optimizing interconnected system. Future studies explore automated graph combination for big data analytics. So, till once, let us revise once again what we have discussed to our PPT. So, from this we have learned what a graph combination, introduction to graph combination and graph theory, and types of graph combinations we have learned. These are some examples, and mathematical representation, application in network analysis. That we have many applications in our network analysis. We have saw five types of applications. One is communication network, social network analysis, transportation system, power and utility network, biological and neural network. These are the five applications. Next we have saw advantages and challenges. So advantages are simplify large scale and enhance understanding. Challenges are computational complexity, visualization and data handling. And we learn about a case study example that combining road and communication network, analyze some emergency response system, and union graph shows all possible connections, etc. And intersection graph highlights. Next we have some conclusion. These are the both graph combinations. Thank you.